Hey everybody, this is Mr. Molcash. I'm going to give you some instructions for week 4. Just kind of let me remind you how to get in touch with me. This is my email address. And please use this if you need to contact me privately, if you have a question that is not appropriate for everybody to hear, so we can communicate with each other. And if you're experiencing trouble, please reach out to me as soon as possible. I also kind of want to let you know that if you have a question that's appropriate for the entire class, I just recently created a discussion board, and the thread is called Ask Mr. Molcash. So it has a little smiley face after it. Okay, so I'm going to try to do a better job of answering questions in the discussion board on a timely basis. It took me a couple of days to get used to that kind of thing, so I'll do a better job this week, but just kind of trying to keep up with what's in there, because I do have to go back and check it. I don't get notified when someone posts in there, so I'll work on doing a better job with that. So this week in the text, we're looking at section 4.7, and that is a section about inverse trig functions. So just let me tell you a little bit about the inverse trig functions, and then I want to tell you a little bit about the unit circle, which you've been dealing with for the past couple weeks. Okay, and then what to expect coming up next week. In week 5, you'll have your first test. So I want to give you some strategies so you can study for that test, and then I'll give you, a few more things in next week's video for that. Okay, so why do we have an inverse trig function? Well, first off, why do we have inverse functions at all? It's so that we can undo something, right? So if you say, I have to solve this equation, x plus 5 equals 7, the way to solve this, of course, is to subtract 5 from both sides. But the reason that you do that is that you subtract 5, being that subtraction is the inverse of adding. So whatever is done to this variable, you want to invert that process. So I'll subtract 5, and that undoes the adding of 5. And so these inverse operations undo each other, and you're left with x, right? All right, similarly, if you were to say do the inverse of multiplying, the inverse of multiplying is dividing. So these inverse operations, they undo each other, and you're left with x, right? So say, for example, you have the sine of x equals 0.5. And you have to figure out some angle, whether it be in degrees or radians, whose sine is 0.5. So one way you can do that, first of all, you wouldn't divide by sin, because that's not a number times x like the 2 is. This is an operation being done to the x. So you can think of the sine as being like this plus or the times or the square root or that kind of thing. So don't divide by sin. That's a sin. Haha. LOL. So what we do to both sides, instead of subtracting or dividing, is you do the inverse of sine of both sides, right? I'm going to try to fit that in there, inverse sine of 0.5. And you can do this in your calculator, or you can use the unit circle, and we'll talk a little bit about the unit circle in just a few minutes. But these two things, for all intents and purposes right now, undo each other, and so you get x. There are times when they don't undo each other, and you'll experience that kind of thing in lab 2 in a couple of weeks. You'll see what happens there, but right now we're good. And if we do this in degree mode in our calculator, you'll get 30 degrees. 30 degrees in radians is pi over 6 radians, okay? So practically speaking, the reason that we would want to do an inverse is to find the measure of an angle, say in a triangle. So, maybe you'll have a word problem where you'll have, say an angle of elevation. Angle of elevation. Some of you were struggling with that first couple weeks. So angle of elevation means moving up from horizontal. That's the angle of elevation. So let's say that, we're a certain distance away from a building, maybe we're 10 feet away from a building, and we know that the ladder has to move up at 8 feet, and that ladder is really not steep enough for you to step on if that's the case. But let's just say that we want to figure out what angle is going on right here. So because we know the opposite side and we know the adjacent leg of the triangle, we're going to use the tangent function. So we'd write an equation, tangent of x equals opposite over adjacent. And then the way to solve that is to use the inverse tangent function, right? So inverse tangent of both sides of this equation, right? Okay, so when you do that, again, for this triangle, these definitely undo each other and you're left with x. This you can input into your scientific calculator. And just real quick, I'm going to actually use my web browser calculator here. And I'm going to see, I want to be in degrees, and I want to do the 8 divided by 10. So that's going to give me 0.8. And then I want to do the inverse tangent of that. And my calculator tells me that this angle is 38.6598 and some change degrees. And usually, you can round off to like the nearest tenth. So, 38.7 degrees is how steep the ladder is from the ground, and that's called the angle of elevation. All right, so again, it depends on what sides you have. You might use sine or cosine to do that kind of thing. Okay? All right, another problem that we'll have to deal with is sometimes these sides are not numbers, they're variables, right? So let's say that we have an angle theta, right? We'll call that theta now instead of x, and we'll have a length here that's 10, and then this is an unknown length, right? So we have all different kinds of angles of elevation depending on how long x is. And you can just tell by common sense that the longer the x is, the steeper that angle is going to be. It's going to have to move up the wall, so to speak. The smaller the x is, the more shallow that angle is. But what we're going to want to do is to create an expression for theta. So we're going to write theta as a function of x. And one way to do that is to, again, use the tangent function, because from theta we know that x is the opposite side and 10 is the adjacent. So what we can say is the tangent of theta is x over 10. So when we invert the tangent, we get theta is the inverse tangent of x over 10. And now theta is written as a function of x. Okay? Let's say that you needed to use sine or cosine, and we wanted to figure out how long this hypotenuse was. Don't forget, if you know two sides of a triangle, you can always use the third side, find the third side by using the Pythagorean theorem. So you would say 10 squared plus x squared equals question mark squared, right? And so that question mark, to figure that out, I have to take the square root of both sides, right? So the question mark then is the square root of 100 plus x squared. Now, you might be tempted to cancel these out and get 10 plus x, but don't do that. There's a plus sign there. These terms are added, not multiplied. You can only cancel these things out in multiplication. All right, so this is the square root of 100 plus x squared. So if you wanted to, you could say, I'm moving this over to make sure we're on the camera here. Yeah, you could say, for example, the sine of theta is the opposite over the hypotenuse. This looks a lot more complicated than the tangent one, which of course is the reason I did that one first. But another possible answer for this would be that theta is the inverse sine of this big mess that we have written here, x over square root of 100 plus x squared. And that would be an acceptable answer. And you can use the Desmos graphing calculator and actually graph both of these expressions, and you'll see that for theta between 0 and 90 degrees, these are functions that are exactly the same graph, so they're equivalent to each other. Interesting stuff, right? Okay, I do want to spend some time talking a little bit about the unit circle that you have come to know and love. And I just want to show you the first quadrant of the unit circle. First quadrant. So this is x, this is y. This entire length is 1. So this point on the graph is 1, 0, and this point is 0, 1. Okay? So very quickly, to get the other values very quickly without having to use your calculator or waste too much time, let's say that you're under a time crunch on the first test, for example, right? So here's a point, and then there's 2 on either side of it. These points, and these points are the same distance apart along the arc of the circle here. All right, so this would be positionally 0 degrees. This is 30, this is 60, and this is 90. And if you split the difference between 30 and 60, you get 45. Okay, I trust that you know how to convert each of these to radians by now. So you may have to go back in Alex and learn that concept if you need to. But remember, too, that this is the cosine and sine of each angle on the circle, right? And I'm only doing the first quadrant here because I feel like if you know the first quadrant, you can automatically translate that, or rather reflect it even, over to other quadrants. So here's a real quick trick, okay? What we want to do is start with 0 and then move up, right? So what we're going to do is we're going to start with 0. We're going to do 1, 2, 3, 4. Okay? What we do with these numbers, all 5 of them, 0, 1, 2, 3, 4, is you square root the number and then divide by 2. Square root the number and divide by 2. And you may be saying, hey, Mr. Molikash, why didn't you put the square root over the 1? Well, the reason for that is that the square root of 1 is 1. But the square root of 2 is some crazy decimal, and I don't know that, so I'm just going to leave it square root of 2. So for that reason, I'm going to do the same thing here, square root of 3 over 2. And what's the square root of 4 and then divided by 2? Well, it happens to be 1, which I've already put there, right? Now, see all these numbers? These are the sine, S-I-N-E, of each angle. So the sine of 0 is 0, the sine of 30 degrees is 1/2, and as we saw earlier, the sine of 30 degrees really is 1/2, right? So this is all displayed on the unit circle. So these are the sines, and the cosines, you just write them all backwards. So take all these numbers and write them all backwards. This is 1/2, this is square root of 2 over 2, this is square root of 3 over 2, and of course that's 1, which is the square root of 4 over 2. So that's a real quick way to do the unit circle. Nice little study tool for you. Some easy, quick access to do that kind of thing. And then, very quickly, like if you needed to do, say, the inverse sine of 1/2, I got to figure out what that is, right? So that's some angle. And if I'm looking at all the sine values, which are the second coordinates here, the inverse sine of 1/2 is 30 degrees, right? I can easily see that just looking at the unit circle. So that's real quickly. That's what's going on. Again, please reach out to me by either using the discussion board or sending me an email. Try to stay up with Alex. I know Alex is a bit of a challenge for some of you. I know you have to, require some time and that kind of thing. But just, I'm checking to make sure that you guys are just kind of keeping up with the content. And if you're stuck, please don't wait. Reach out to me, okay? So I'm here for you if you need help. Thanks so much. Hope you have a great week.